Hello everyone, I am Vaibhav shah and our today's topic is engineering curves and we will be learning how to draw an ellipse. So let us begin. So first, problem number 1. Major axis of ellipse AB and minor axis CD are 100 and 70 mm long respectively. Draw an ellipse by arc of a circle method. So here, as the name suggests, we will be drawing this ellipse by circular arcs. That means we will be drawing this ellipse by usage of rounder. So now here two data are given. First is the major axis of ellipse and second the minor axis of ellipse. So let us begin the construction of ellipse by arc of a circle method. So let us first construct the horizontal line, which is nothing but the major axis of ellipse. So you will be drawing this horizontal line of 100 mm like this. Then after, let us give the notation to that line as AB. Then after, find out its midpoint of this horizontal straight line, and from that line you will be constructing one vertical line which is nothing but the minor axis of ellipse. After drawing the minor axis, we will be notified that minor axis as CD. So let us put C and D on your minor axis. Now thereafter, always remember, we require a total of 3 data in order to construct our ellipse. First, its major axis, second, its minor axis, and third, the focal points F1 and F2. Here, the focal points are not given in your example. So first task for us is to find out the focal point F1 and F2. So always remember, as per the definition, ellipse is a locus of point P moving in a plane such that sum of its distances from two fixed points F1 and F2 remains constant, and that is equal to the major axis of an ellipse. So by using that phenomena, let us draw the ellipse. So what we will do is, we will first find out F1 and F2. So let us take the half of your major axis as your distance. So we will be taking a rounder. Put your rounder at point O or center point O of this intersecting axis. Then after, take the distance from your center till your point A. So we are taking half of your major axis distance. Then after, let us put your rounder onto the C point and let us make one arc on the left hand side in order to get your focal point F1. Then after, let us put the rounder once again on C, and this time let us make arc on the right hand side of your ellipse in order to get your point F2. Then after, let us notify these points as F1 and F2. Now, then after, what we need to do? So let us take any arbitrary number of points between the F1 and your center. So here we will be taking any number of arbitrary points between your centers F1 and your center of your axis. So let us take these points 1, 2, 3, 4. You can take any number of points between this center, but I would suggest always take 4 minimum points or maximum of 5 points. You can take these points at whichever distance you like. But here we are taking these points like in this manner. So now let us give numbering 1, 2, 3 and 4. So now let us observe what we are going to do in this example. So now let us take out our rounders. Now put your rounder at point A and take the dimension of A1 onto your rounder. Then after, let us put your rounder at F1 focal point and let us draw one arc like this. So then after, let us put your rounder at point B and take the dimension of B1 onto your rounder. This time let us put our rounder at focal point F2 and try to cut the previously drawn arc like this. Now then after, let us put your rounder at point A once again. Take the dimension of A till 2 onto your rounder. Now this time put your rounder at focal point F1 and try to draw another arc like this. Then after, put your rounder once again at point B, take the dimension of B till 2 and put your rounder at F2 to cut the previously drawn arc like this. Then after, put your rounder once again at A, take A3 distance on your rounder, put your rounder at F1 and try to draw the arc like this. Then after, put your rounder on point B, take B3 distance on your rounder. Now put your rounder at F2 cut the previously drawn arc like this. Then after, put your rounder at final point A till 4. Now put it on your F1 center and try to draw the arc. And then after, let us put your rounder at the point B. Take B till 4 distance onto your rounder and try to cut your previous drawn arc like this. So by cutting these points, we will be having some points of intersection like this. So let us highlight these points of intersection. So we have got a total of 4 points, right? So now let us give the numbering as P1, P2, P3, P4 like this. So we have constructed the quarter of your ellipse, right? So now let us follow this procedure on another side. So when we are following the procedure on the right hand side part of your ellipse, we will be having another 4 points. And by defining these points, we can identify these points by dark points like this. So then after, we need to follow this procedure to 4 of the quadrants to get your ellipse done. So we'll be following this procedure to get these 4 points, and another 4 points on your left hand side quadrants. So after getting all of these 4 points, by following the similar procedures on each of the quadrant, we are getting the ellipse. And here, as you can see, we have drawn this ellipse by the help of your circle or the circular arcs. That's why this method is widely known as your arc of a circle method. So now let us see one another method. So here let us read the example. Draw an ellipse by concentric circle method. Take the major axis as 100 mm and minor axis as 70 mm long. So here also we have 2 data. First is the major axis and second is your minor axis. But here our method is what? Concentric circle method. Concentric circle means what? Concentric means coinciding centers. So we would be having 2 circles whose center point would be a same point or coinciding point. And from the same center point, we will be constructing that circles, and that's why these circles are known as concentric circle method. So here we are having 2 data. First is the major axis and second is the minor axis. So what we'll do is, we'll try to generate 2 circles by taking a diameter first as a major axis, and second we'll be generating another circle with the diameter as minor axis. So let us first take the center and let us draw the major axis first. Then after, let us take the minor axis. Then after, take out your router and first take your minor axis as your diameter, draw one circle, and then after, let us draw one circle with major axis as a diameter, like this. So we have drawn 2 circles, first with the minor axis as a diameter and second with the major axis as a diameter. Let us describe this major axis as AB and minor axis as CD. So now let us divide this circle into 12 number of equal parts. So always remember, whenever you are having circle into your engineering graphics subject, you will be either dividing the circle into 8 number of equal parts or either 12 number of equal parts. So here we will be dividing this circle into 12 number of equal parts. So let us divide this circle into 12 number of equal parts. So if you don't know how to divide the circle into 12 number of equal parts, then kindly go and refer my previous lectures based on geometric construction, in which I have taught you how to draw or how to divide your circle into 8 number of equal parts or either 12 number of equal parts. So let us divide this circle. Then after, let us give numbering as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because here we have given A and B as a numbering, so we will be having only 10 numbers. And then after, let us give the same numbering pattern to your inner circle also. So let us give numbering from 1, 2, 3, 4, 5, 6 in a similar fashion to inner circle. Now then after, what we need to do? So here we have 2 circles. So the larger diameter circle is known as a major circle and smaller diameter circle is known as your minor circle. So always remember, we'll be trying to draw the vertical line from the points on your major circle, and we'll try to draw horizontal lines from the points on your minor circle. So let us draw vertical lines from a point on your major circle, means from your outer periphery. So let us draw vertical lines like this. 1, 2, 4, 5, this. Now it is the time to draw horizontal lines from the point on your minor circle or your smaller diameter circle. So let us draw horizontal lines from your points on a minor circle. So let us draw horizontal lines like this until you intersect your previously drawn vertical lines. So in order to get your points of intersection like this, so finally you will be having these points. Then after getting these points, highlight these points by darker points like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So here we have highlighted all of the points. So next task is to just join these points by a darker line. So let us connect these points by a darker line in order to have our ellipse generated. So let us join these points by a smooth curve. So you can join it by a free hand or you can use your French curves in order to join these points. So let us join these points. So this is nothing but what? It is your ellipse by concentric circle method. And then after drawing the ellipse, you should give the dimensions. So here I have not given the dimension, but for your examination purposes, you should always give the dimensions to your figure. So now let us move ahead and let us see one more example. Draw ellipse by rectangle method. Take a major axis as 100 mm and minor axis as 70 mm long. So here you will be constructing your ellipse, as you can know. A rectangle method, that means we will be now constructing your ellipse into one rectangle. Right, very easy. So now we will be constructing the rectangle by given dimension 100 mm by 70 mm. So let us construct first a rectangle of 100 mm by 70 mm. So you have drawn the major axis of 100 mm and find out the minor axis CD, which is of 70 mm, which is 35 mm above your major axis and 35 mm below your major axis. Then after let us complete this rectangle. So after drawing this rectangle, we will be dividing this vertical line over your point A into 4 number of equal parts. 1, 2, 3 and 4. So 1, 2, 3 and 4. Now always remember, if we are dividing the vertical line into 4 number of equal parts, that means we should divide the horizontal line from A till the center point or intersection of axis also into similar number of equal parts. So let us divide that line also into 4 number of equal parts. So like this, 1, 2, 3 and 4. Fourth point would be the center point. So let us define the points 1, 2, 3 and 4. So here you should remember one thing. If you are dividing the vertical line into 4 number equal parts, that means that you must divide this horizontal line between your A and center point of your axis also into equal number of equal parts. I would always suggest that try to take minimum of 4 parts and maximum of 5 parts of both the lines, right? So let us move ahead. So here now we try to join the number 1 point with your point D. Now point 2 with point D, point 3 with point D, and number 4 is already connected with point D. Now then after what we need to do, we need to draw one line from your point C, passing from your 1 and touching your 1 line. Now draw a line from C once again, passing from your 2, touching your 2 line. Draw one line from C, passing from your 3, touching 3's line. Draw a line from 4, passing from the 4 and touching 4th line, which is already your point D. Now then after what we need to do, we need to just highlight these points of intersection. So let us highlight these points of intersection like this. So after highlighting these points of intersection, we need to just generate the curve, right? It is very easy. So let us follow the similar procedure on the right hand side of the rectangle. So let us follow the similar procedure. So now we have taken the vertical line divided into 4 number of equal parts. So let us give numbering 1, 2, 3, 4. So always we are starting from lower bottom point from your point B as a 0. So 1, 2, 3 and 4. Then after what we need to do, we need to divide the horizontal line into 4 parts. We have divided the horizontal line also into 4 number of equal parts. Then after let us simply follow the procedure. Let us connect your point 1 with your point D, 2 with your point D, 3 with your point D and 4 point is already connected with point D. Then after let us construct one line from your point C, passing from your 1 number point touching your first line. Then after draw one line from C once again, passing from your 2 number point and touching 2's line. Then draw one line from your point C once again, passing from 3 number point and touching 3's line. And now let us put your scale onto your point C and let us draw one line passing from 4 and touching your 4th line, which is nothing but what? It is your point D. So then after let us highlight these points once again like we have done previously, and then after let us join these points. So we have followed this procedure. So this is nothing but what? A rectangle method. So you need to follow this method in order to get the ellipse in the lower half. So let us follow the similar method in order to get the ellipse in the lower half. We'll be drawing the ellipse in the lower half like similar method, right? So it is very much easy. So this is nothing but your rectangle method. We are actually constructing the rectangle, and into the rectangle we are actually putting the ellipse, right? So let us move on. Then after let us move to our next example, problem number 4. Draw an ellipse by parallelogram method. Draw a parallelogram of 100 100 mm and 70 mm long sides with included angle of 75 degrees. Inscribe ellipse in it. So here note that the steps are very similar to your previous example. The difference is that here in the place of rectangle, we will be constructing parallelogram. So let us first understand what do you mean by a parallelogram. As the name suggests, parallel, that means the construction of this element is such that the two opposite sides must be parallel to each other. So let us construct one parallelogram and let us understand what I mean by a parallelogram. So this is a parallelogram. So as you can see, these two vertical sides are at certain degree angle, but they are parallel to each other. As well as there are two horizontal sides which are also parallel to each other. Parallel means each of the points of both of the lines are at equal distance from each other. Right? So now here, how to construct this parallelogram? So always remember, in parallelogram example, these things are 100 mm and 70 mm long sides are never your major axis or minor axis. These are only the sides of your parallelogram. So always remember that these are not major axis and minor axis of your parallelogram. So we must construct the 100 mm as a horizontal line, and then after we should construct this vertical line as 75 degrees to that horizontal line in order to construct your parallelogram. So we have constructed this parallelogram by drawing this horizontal line, and then after constructing this 75 degree line from your horizontal line in order to complete this parallelogram. After getting this parallelogram, what you need to do is, you need to find out the midpoint of each of the four lines, and we will be constructing and we will be dividing this parallelogram into four equal sections. So let us divide this parallelogram into four equal sections by finding the midpoint of these vertical lines first, and then after finding the midpoints of that horizontal lines. So we will be having 2 points A, B and C, D. But remember once again, these are not your major axis or minor axis for ellipse. Okay, so now let us follow the similar procedure. So we will be dividing the space above your point A into 4 number of equal parts like this 1, 2, 3, 4, and then after we will be giving numbering starting from A as a 0. So let us give numbering as 1, 2, 3 and 4. So now you should divide the portion from A into your right hand side until your intersection point also into 4 number of equal parts like this. Thereafter, let us give numbering as 1, 2, 3 and 4. The fourth point would be the intersection of two lines, right? So now let us begin. So what we need to do next, we need to draw one line from your point 1 and touching your point D at the top. So let us draw one line. Similarly, draw lines from 2 till D, 3 till D and 4 point is already connected with D. Thereafter, what we need to do, we need to draw one line from your point C, passing from your 1 point on the horizontal line and touching your 1's line. Let us draw another line from your C, passing from 2 and touching your 2's line. Let us draw another point from C, passing from 3 and touching your 3's line. So let us draw another line starting from point C, passing from your point 4 and touching your 4's line, so which will give you point D, which is already there. So then after, what we need to do? We need to just highlight this point. So we'll be starting from the point A because it would be the starting point of ellipse. So let us highlight these points by this dark point like this. Then after, let us draw the similar procedure on the right hand side half of your parallelogram. So what we need to do? We need to divide this vertical space into 4 number equal parts. Then after, we need to divide this horizontal space also into 4 number equal parts. Then after, let us start joining the points with your point D. So 3 to D, 2 is connected with D and 1 is connected with D. So we need to draw the line starting from your point C, passing from your point touching the 1's line. Draw one line starting from your point C, passing from your point 2 and touching 2's line. Draw one line passing from your point 3 and touching your point 3's line like this. Then after, identify these points once again by darker points like this, right? Very easy. Then after, connect this half, first half from the left hand side, and then after, connect your second half on the right hand side. Now we need to follow the similar procedure for another half, but let us understand one easiest shortcut method in order to transfer the same points without redrawing this same procedure into the 4 of the halves, because it will take a lot of time to construct your ellipse by parallelogram. So you will be here using a shortcut method. It is also known as a mirror line method. So what we need to do? So we'll be now drawing the points from each of the points on ellipse on the upper line of your horizontal line or horizontal axis. So what we are doing is, so you need to draw the lines parallel to your vertical line, which is 75 degrees, by the help of roller scale rounder like this. Now this line must be at the equal proportion from your center line. So let us suppose if I take one example. See, this is the line starting from your center axis till your 1 point. So you need to take the dimension of that line, and you need to produce the same dimension from your center line to the downward direction onto that line, and you will be having the end point as your ellipse point. So here what we are doing is, we are defining one center line. So center line is what here in this case, AB is your center line. So you will be taking the equal distance. So which is the distance from your B line, AB line to your point 1. On the above side, you need to take the same distance onto your rounder. You need to plot the same distance on that line below that line. So you will be having points for each of the cases. Then after getting the points, you need to simply connect these points in order to get your ellipse done. So let us connect these points. This is nothing but what? Ellipse by parallelogram. So now, what is the difference between ellipse generated by rectangle method and what is the difference between parallelogram method? So rectangle method and parallelogram method both are same. But here the difference is, in rectangle method, the degree between the two lines, horizontal as well as vertical lines, is 90 degree, wherein here in our case, the degree between this horizontal line and this inclined line is 75 degree. That is the main difference. Second difference, in the rectangle method, the horizontal line and vertical lines are the major axis and minor axis of ellipse, but in this case, the horizontal line and this inclined line are not the major axis and minor axis of your ellipse. So always remember. So now let us move ahead and let us see one more example. So now before moving to this example, let us understand how to draw the ellipse by this method. So this is the method which is known as directrix focus method. So let us understand step by step procedure to draw ellipse by this method. So let us suppose we have a data given. So first the data is given like the distance between your focus and your directrix is given. And second data which must be given into your example, which is your eccentricity ratio. So here in our case also, let us assume that we are given with two data. So now here you can see on the first diagram on the top left, so you can see that the distance between your focus and directrix is given as 50 mm, and the eccentricity ratio is given by 2/3. So you should first check the eccentricity ratio. So here the eccentricity ratio is less than 1. That's why this curve would be your ellipse. It's definitely an ellipse by definition. So if you don't know why that 2/3 is less than 1 and why I call that curve as ellipse, you first go and check my previous lecture based on Introduction to Engineering Curves, and you would know why I am telling that when the eccentricity is less than 1, the curve would be your ellipse. Now, let us move ahead. So now what do you mean by eccentricity? Let us first understand that. So it is the ratio of your distances from focal to vertex divided by vertex to directrix is known as eccentricity for ellipse. So here focus to vertex distance is what? F1 V1 divided by V1A is nothing but what? Your eccentricity, as you can see in the figure. So now what we need to do? So let us take, if the focal to vertex distance is equal to 2 parts distance, as you can see from eccentricity ratio here, and then after you know that vertex to directrix distance is equal to 3 parts. So how many number of total parts? Let us give the summation of this total digits. So we will be having total of 5 parts. So what we need to do? We need to divide the line between your focus and directrix into now 5 number of equal parts. Into these parts, we will be defining first 2 parts by your focus to vertex distance, and we will be defining another 3 parts by vertex to directrix distance. So let us understand how would I divide this line. So first let us construct one vertical line. So this vertical line is nothing but what? It's a DD. So DD vertical line is constructed arbitrarily by any arbitrary length. Then after, let us draw one horizontal line from any arbitrary point, and let us define the starting point of that horizontal line as point A. Then after from point A, you should draw your distance between your focus and directrix, which is what? 50 mm. So let us draw 50 mm onto that line. So you will be having your final point F1, as you can see on my first figure on the left hand side. Then after defining your focal point, let us go ahead and see in the diagram that f1 v1 is equal to 2 parts distance. So here, we have total line of what? 50 mm, and the total distance is divided into what? As you can see, we have done the summation 5 parts. So let us divide the 50 by 5. So we will be having a single part dimension which is nothing but what? 10 mm. So now we know that f1 v1 is what? Is equal to 2 parts. We should take 20 mm for f1 v1. So from f1 point you should go on the left hand side for 20 mm and you will be having that point as v1. So let us mark that point as v1 first. Then after, it is automatic that if the 20 mm distance is between f1 v1, then another distance would be obviously 30 mm. So which is our required answer, which is the distance of v1a, which is equal to 3 part, and the single part dimension is what? 10 mm. That means v1a distance must be your 30 mm. So we have identified the points f1, v1 and a on this horizontal line. Then after, what we need to do? So let us take out your rounder, take the radius is equal to f1, v1 and draw one vertical line from v1 perpendicular to your horizontal line, and thereafter v1 as a center, f1, v1 as your radius, draw one arc in order to cut this vertical line. After cutting this vertical line, you should give that vertical line as your point B. So let us define that point B. So we have completed the construction for first figure on my left. Now let us see second figure just below that figure. So in which what we need to do? So you need to draw one line starting from your point A, passing from your point B like this. This will be your inclined line. Thereafter you should construct another line which will be of 45 degrees starting from your focal point F1, as you can see on my second figure just below my first figure. So then after these two lines will intersect at certain point, and from that point you should draw one vertical line, and this vertical line would intersect this horizontal line somewhere, and this point would be nothing but your V2 point, that means the second vertex point of your ellipse. After getting the distance between vertex point V1 and V2, we should divide this particular distance into some equal number of parts. So let's say if the distance between V1 and V2 in my case is 12 mm, then I should divide V1 V2 into 12 number of equal parts. You should divide the line into some equal number of equal parts. Then after dividing this horizontal line into some equal number of equal parts, you should draw vertical lines from each of the points until it intersects the inclined line of AB. So let us draw vertical lines from each and every point, as you can see in my second figure just below my first figure. Thereafter, let us come to the third figure here. So in which what we need to do? So now let us take out your rounder. Take the dimension of 1 dash on your vertical line and take the dimension of your rounder. Put your rounder at your focal point F1 and try to cut your 1 dash line from your focal point F1 as a center. Above and below this line you will be having 2 points which are nothing but your T1 points. Then after, let us take the dimension of 2 dash on this vertical line, and then after put your rounder at focal point and try to cut the line 2 dash from your focal point above and below. You will be having your point P2. Then after take the distance of 3 dash on this vertical line. Then after put your rounder once again onto your focal point and try to cut your line 3 dash. You will be having point 3 and P3. Similarly, you should draw a number of points until you reach your vertex point. So after that, you will be having a number of points like this. And then after connecting these points, you will be having your final ellipse in this case, so which is nothing but your ellipse constructed by directrix focus method. So you have constructed your ellipse by use of directrix as well as focal point F1. So this is known as your directrix focus method. So let us see one example and let us understand very easily. So now problem number 5. Draw an ellipse if the distance of focus from directrix is 35 mm and the eccentricity is 3 by 4. So here let us follow the procedure. So first you need to draw the directrix, which is DD dash, as you can see directrix. Then after you should draw a random horizontal line like CC dash, as you can see. Then after what we need to do? So here let us define. So what is eccentricity? Eccentricity is what? 3 by 4. So that means what? We have eccentricity E is equal to FV, focal to vertex distance, divided by vertex till direct distance, which is FV divided by C, which is equal to 3 by 4. So here 3 and 4. So we will be having total divisions of line is equal to what? 3 plus 4 is equal to 7. So here our line length is what? It is a 35 mm line, because the distance between focus and directrix is what? 35 mm. So we should divide this line, 35 mm line, in order to get your focus point, vertex point and your point on directrix by the given ratio 3 by 4. So what we need to do? So we know that we should divide this line into what? 7 number of equal parts. So for that, let us first find out the dimension of a single part. So for finding out the dimension of single part, what we need to do? Let us divide 35 mm by 7. So you will be having 5 mm, which is the dimension of a single part on that line. So now we know that the FP distance, that means the focus to vertex distance, is equal to what? 3 parts distance. So here the single part dimension is what? 5 mm. So let us multiply 3 by 5. So we will be having FP is equal to 15 mm, as you can see. Then after we know that the directrix to vertex distance is what? It is equal to 4 parts. So we know that single part dimension is what? 5 mm. So let us multiply 4 by 5. So we will be having a 20 mm. So let us draw 15 mm from your focal point on the left hand side in order to get your vertex point, and then after 20 mm from your vertex point till your directrix. So we are having each of the points. So then after what we should do? So let us draw one vertical line from your vertex point like this, and then after take the radius is equal to vertex point till focus point onto your rounder. So VF onto your rounder. Take V as a center and F as a radius. Let us draw one arc in order to cut this vertical line at point A. After cutting this vertical line at point A, we should join this line from C, from passing from A. So we will be having one inclined line, as you can see. Then after you should construct one another line which will be passing from your focal point, and which should be at 45 degree like this. So these both lines would intersect somewhere like this here, and you will be having that point as point B. After getting this point B, simple, you should draw one vertical line and we will be having this point as what? Point V dash. So after getting distance V and V dash, we should divide the distance into particular number of equal parts. So here let's say the distance between V and V dash in my case is 120 mm. So that's why I have divided the line into 10 number of equal parts. So now, after dividing the line into 12 number of equal parts, that again numbering to the horizontal line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 onto the right hand side until you reach the V dash. Then after let us draw vertical line from each of the points like this. So we'll be constructing vertical lines from each and every points like this until we reach the inclined line of AC. Then after what we should do. So let us take our rounder. Take the dimension of 1, 1 dash on this vertical line from your rounder and put your rounder at your focal point F and try to cut this vertical line 1, 1 dash above and below. So you will be having point P1 and P1 dash. Then after let us take the dimension from your vertical line 2, 2 dash on your rounder. Put your rounder at your focal point and try to cut this line 2, 2 dash. You will be having 2 points P2 and P2 dash. Then after let us put your rounder onto the vertical line 3, 3 dash. Let us take the dimension of 3, 3 dash. Put your rounder at your focal point F and try to cut this line 3, 3 dash above and below. You will be having this arc generated by P3 and P3 dash. Similarly, try to find out the arcs for each of the points until you reach your final vertex point. So you will be having number of points generated until you get P12 point. And after getting your P12 point, you should simply connect these points by a dark smooth line, either by the help of a French curve or you can join it by a smooth line. So you will be having one curve generated, which is nothing but what? It is your ellipse generated by directrix focus method. Very easy. So these kind of examples are usually asked in your examinations. So you should practice this directrix focus method because it is generally asked in your examination. So let us move ahead, and now let us try to draw tangent and normal to the curve from a given point Q. So here we will be directly taking the ellipse, and you can draw ellipse by virtually by any of the methods previously learned method. So let us suppose we have taken the ellipse, we have drawn this ellipse by the arc of a circle method. So this is our ellipse. So now, here we will be selecting any point, random point Q onto your curve, and on that point we should construct our tangent and normal. So let us select any point Q on this curve. So we have selected this point Q somewhere there. Then after you should connect this point Q with your focal point F1 as well as your focal point F2. So let us construct and connect your point Q with F1 and F2. So now as you can see, the one angle is generated which is nothing but F1 Q F2. section of angle method in order to divide this angle into two equal halves. So by dividing these angles into two equal halves, we will be having one line generated, which is nothing but your normal. So let us divide this portion by bisection of angle method into two halves. So by using that method, we will be having one line generated, which is nothing but what? Normal. And drawing a line perpendicular to this line will generate a tangent. So this is nothing but what? A tangent. So tangent is a line which is passing from only a single point and outermost point of your curve. So this is nothing but what? A tangent. So let us write down normal and tangent. So let us see one more method to draw tangent and normal to the curve from a given point Q. So let us select any point Q onto the curve like this. Thereafter what we should do? So we should construct one line connecting to your focal point F1, and from then on we should construct one line at 90 degree to that line connecting your point Q and F1 like this. So let us construct one line at 90 degree from your line like this. So we will be having that line intersecting somewhere onto your directrix. After getting the intersection point onto your directrix, you should mark this point onto your directrix and connect your point Q. You will be drawing one line which is nothing but your tangent, and you should draw one line perpendicular to that tangent line at the point Q. You will be having normal generated at the same point. So then after we should define the tangent as TT point and normal as AN point. Right? So it is very easy. So we have taken this ellipse from your directrix focus method. You can have ellipse by any method, but you should have a focal point and directrix in order to draw tangent and normal by these methods. These are the two methods you can draw tangent and normal to any of these. So that is all from my side. If you enjoyed my content and teaching style, do not forget to like, share and subscribe to my channel. If you have any doubts, any queries, feel free to ask and comment down below. Keep learning, stay connected. Bye bye.